last two theorems will be, again, you don't have to worry about this for your exam. It's for your IGCSE in November. So these are the two for the worksheet 5 and 6 circle theorem that I gave out today. Can I have your worksheet 5 and 6 circle theorem? Okay, and the 6. Okay, so the first one is a tangent. It's about tangent. That's the easiest one. So I'll just say tangent to circle. Does anybody know about tangent, the relationship between tangent and the circle? Anyone? Yes, sir.
Like 1 point.
So it touches at 1 point. I love that. What else can you tell us about that? A tangent is that straight line that touches the circle at 1 point. Only 2 people. So this is tangent, right? So the circle has the center O. Nobody knows anything else apart from these guys. Yes, sir. Quickly.
If there's an angle from the point in the tangent leading to the midpoint of the circle, it forms 2 right angles.
What do you mean? I draw a line?
Yeah.
Like this? Okay.
And then it forms 2 right angles.
It is perpendicular to the radius. That's what I was expecting. Are you having any other information, or that's what you want to say? So a tangent is that straight line that is always perpendicular to the radius. That's all. It touches at 1 point and it's perpendicular to the radius. So a tangent touches, not cuts. Touch means 1 point. Cut means maybe more than 1 point. This line cuts the curve. But this line touches the curve. Can you see the difference? Okay, the one that touches the curve is a tangent. Does anybody know the one that cuts the curve? What is it called? Yes. Say that again?
Is that chord?
The chord language is used in the circle. Yes, ma'am.
Bisector.
A sector, no. Bisector, no. Bisect means cut in half. There is no guarantee that this cuts in half. It's called a secant. Secant. This is a tangent. Those are the 2 important lines. Anyway, but you don't need to worry about secant. So a tangent touches a circle or any curve actually, but we are focusing on the circle because this is circle theorem. Okay? It touches a circle at only 1 point. Okay? It is perpendicular to the radius. Those are the 2 things that makes it a tangent. It's perpendicular to the radius, according to Mr. Tamash. Okay? So this is why we, now, because it's perpendicular to the radius, do you think we can form a right angle triangle?
Mm-hmm.
Yes. So if we have this, then that's a right angle triangle for you. Okay? And if it is a right angle triangle, you can do angle in the triangle is 180 if the problem is about the angle. You can do SOHCAHTOA if this is unknown. If you are relating to be 2 sides and 1 angle. You can use Pythagoras theorem if you are trying to find whatever. Do you understand that? And that's what this worksheet is about. Okay? That's what the worksheet is about. So I'll just write maybe 1 or 2 we do together, and that's it, and I move to the other one. I want to be as fast as possible. Hope I'm not rushing it too much. Okay, quickly. Ms. Roslyn and I agreed that we start cleaning up by 4:05. So we're not going to wait until 4:20 to clean. Let's just Maybe I'll just take the exact question in this paper. Take one on one page, take one on the other page. Here is one of them. It says find x, whatever x stands for. That's a tangent, so there's a tangent here. This is joined this way. This is 25 degrees. X is AB. O is the center. And this is 20 centimeters. How can I find x? Divino. Can I ask you a question? You have 2 seconds. Thank you. SOHCAHTOA. Which of these trig ratio in SOHCAHTOA do we use? Raise your hand if you know. Yes, Thomas.
Cos?
Cos. John, do you agree with him? Okay. So because we know this is perpendicular, right? This is perpendicular, so we say cos 25 degrees is equal to opposite, no, adjacent, sorry, over hypotenuse. Is that not? You may begin by saying cos theta is equal to adjacent over hypotenuse. Then I substitute. Understand? You don't even need to write this AB stuff. Just write it as x over 20. Right? If this is perpendicular, this is hypotenuse, this is adjacent, because this is opposite of 25. Remember that? Good. So x is simply 20 multiplied by cos 25. And whatever you get. I keep telling you, stop calculating what is cos 25, 0 point something. Stop doing that. Leave it as cos 25 until the last step. Okay, so you can get more accurate results. Understand? So press the calculator. Your calculator must be in what mode? Degree mode. Very good. 18.1. Agree with him?
Yes.
Do I need to put a unit?
Yes,
Of course.
Yes.
Degrees?
CM.
cm. Please don't forget your units. Okay? So I write one more. You see, the only thing we are using is that we make sure this is right angle. And the reason why it is right angle is because of what? The reason why it is right angle. No, we use SOHCAHTOA because it is right angle. Why is it right angle? Yes. Yes, sir. Yes, ma'am.
The tangent is always perpendicular to the radius.
That's it. Radius is perpendicular to tangent. So, in a standard exam, well, not Form 3 kind of exam, we will expect you to say, oh, OBA equals 90 degrees. Then in bracket, you write radius perpendicular to tangent. That is how you justify that this is 90 degrees. Understand? But for IGCSE, you can just put this sine 90 degree. The examiner will understand. Okay? So I write 2. For this number 2, 2 tangents are meeting at a point. So this point is an external point. There's a theorem on that tangents that meet at an external point are always of the same length, but we don't need to worry about that. So let's pretend they meet. So this comes like this comes like this. This is x, this is 8 cm, this is 30 cm. What do I do? Think fast. Yeah? Wait, let's see. Sorry. Let's see if there are OA something. Okay, A, B, C. I forgot that. So there's A here, B here, C here, and there's O center. Thank you. Yes?
You connect OA.
Connect OA. Did you hear that? Connect OA. Yes?
And then X is split in half. So
Exactly half. That line is a bisector of that angle. Okay? So these 2 triangles are the same. And they are right angle because of the perpendicularity. Yeah? It's just the congruent property. This is the same as this, right? 90 is the same as 90. Right? This length and this length are the same. Or this common side is the same. They have common side, right? and the two of them must be congruent. Congruent means if they overlap, there's no difference. The exact shape and size. Understand? So, with this now, it's easy. We just find this angle. So if I call this alpha and I call this alpha, it means my x is equal to 2 alpha. Yes? So all you have to do is from one of them, find the value of alpha. Okay? Hello?
Mm-hmm.
So you can say, so you may sketch one of them. B, right angle, alpha, 38. Use your SOHCAHTOA, find alpha, then find x. That's it. Okay? So there's no need to work that out, right? You can work it out yourself. Okay, so that's that. Please write one or two things while I give you a short explanation on the second one. So I put here DIY. We still have about 10 minutes. This will be number 5. So we use V. And this is the last one, VI.
I don't know. Wait, I haven't.
Tanya.
I don't have yours.
Is everything okay?
Yes.
Yes, sir.
Can I go to the toilet?
Don't be late, please.
Aye.
Okay, everyone stop. Again, I apologize for rushing through this, but because it's on record, you're welcome to watch it at your pace and do this worksheet over and over again. For circle geometry, all the worksheets that I've used, don't solve them once. Okay? Solve them more than once. And look for your IDCSE past questions. I'm sure they are online. If they are not, message me. I'll upload everything on the Google Drive for you. I have them on Google Drive. I'll share the link with you. Download these questions and practice. Don't play too much over summer. Dedicate some time to practice. All right? We begin with the meaning of alternate segment. Okay? And I thought the first thing is, what is a segment? We have discussed this before about a segment. A segment is that part. When you draw a line in a circle, you just divide it into two segments. Okay? Sector is the one that looks like pizza, right? Right?
Yes,
Segment is when you draw a line. I think I mentioned segment also the last time. Angle in the same segment are equal, right? So this is a segment, this is a segment. Because this is bigger, we use the word what? To describe it? Major. And because this is smaller?
Minor.
So actually a minor and a major segment, when they are combined, gives you what? A full circle. That was one of the questions we were tricked with when in my high school days. You know, if I give you area of a circle is 22 cm squared, and I say find the area, you can do it, right? Talk to me, please. Yes. But rather than giving us this back in the day, there was a question I remember. I can't remember the figures. The examiner says the area of the minor segment is 6 cm squared, and the area of the major segment is 16 cm squared. What is the area? What is the radius of the circle? The area of the minor is 6. The area of the major is 16. Indirectly, they are telling me what? Is what? They expect us to understand how they combine to form a circle. Understand? Now, you see, this is major, this is minor, right? And they are also on opposite sides. In geometry, we don't use that word opposite. We use the word alternate. So when I say alternate segment, I mean opposite segments. You are on the left of the chord, I'm on the right of the chord. We are alternate segments. Okay? It's like saying they are neighbors, separated by a fence. Am I making sense? Now, why did I mention this? Because of alternate segment theorem, which is the last one. The theorem says, as I'm saying the theorem, I'm going to be drawing the picture. So I need you to think along with me. The theorem says, if a tangent is drawn to a circle, let's draw a tangent to the circle. And at the point of contact, let's find the point of contact. A chord is drawn. Okay, let's draw a chord. Now, watch this. The theorem then says the angle which the chord makes with the tangent. How many ways can the angle make how many ways can the chord make? It says what? The angle which the chord makes with the tangent. So it's about the chord and the tangent, the angle between them. But there are how many ways you can do that? To find the angle between the chord and the tangent. Speak fast, please. 2. This is the chord. This is the tangent. The angle could be this or this. There was no specification. Is that not? So let's pick one of them. Let's pick this one. Okay, so what happened to it? It says that this angle must be exactly the same value, the same measure that this same chord will make in the alternate segment. Are you listening to that? The angle which the chord makes with the tangent, it means the angle of the tangent must be in one segment. Because the next statement is referring to the alternate segment. Looking at this now, this angle purple is in which segment, major or minor?
Minor.
It means the alternate segment is major or minor?
Major.
This is the major, right? The same chord. These two must be the same value. That's what the alternate segment theorem says. we had done this, at least this is also the tangent, right? This is still the chord. You will see that this angle is in the bigger segment now. The alternate will be in the smaller segment. But it is this same chord that makes it. When you say a chord makes an angle, it means the edge come together somewhere. Am I making sense? The extreme will come together to form an angle. So when they form an angle, are they going to form it down or up? With what I'm saying now, this red one. If I'm talking about the alternate segments for this case, is the angle formed going to be down like this one or going to be up? It's going to be up this time. So from the edge, the alternate segment theorem is saying this value must be the same as this value. So I use 3 line, so that it's not mixed. Let's take one more here. But I won't do 2 so that it's not confusing. Let's say I draw a tangent here. And the point of contact, a chord is drawn. Let's have a purple chord this time. Okay? The theorem says the angle which this chord makes with the tangent, if you pick this, is here. Alternate segment is where? Here, right? Then you are talking about when you join this together. This angle and this angle must be the same. If you pick this, then you are dealing with this region. Am I making sense? Then this and this will be meeting somewhere, and that value must be exactly the same as this. That's what the alternate segment theorem is about. Okay? And when you are stating your reason, the only thing you need to write is 3 words. Alternate segment theorem. That's all. Not this 2. Okay? So I'll take 2 questions also from the paper. Watch the video later and do more yourself. I think we have a whole lot of questions. And the question at the back, especially questions 3 and 4, they are IGCSE questions. I think even number 2. So I will just pick from number 1 because of our time. Okay? It's 4:09 my time, which means the other class is ready. Okay, let's just take 1. I just pick 1 question. Okay, so the question is, can you look at it and pick 1 question for me? 1, 2, 3, 4, 5, 6. Which one looks more serious? 6. Okay. Okay. Everyone is setting a trap for me, right? Thank you. It's like, oh, you do the 6. It looks difficult. I know what you're thinking. So this is Y, this is Z, this is X, and 80 is between this and that. Can you see that? So I'm going to label this maybe A, B, C, D. A, B, C, D, and maybe E. Okay? Now, alternate segment theorem works automatically because this is a tangent and this is a chord. Right? Can you tell me which of these angles? Just tell me A, B, C, OA, DAC, that's what I want to hear. Which of them is equal to 80 by alternate segment theorem? ABC. Come on. You should have given him a chance. ABC, of course, right? Because this is the chord, this is the tangent. So the angle which the chord makes with the tangent is the same as the angle which the same chord makes in the opposite segment. Not here anymore. Go up. So x is equal to what? Automatically? And since x is 80, y is what?
160.
160. If y is 160, z is what?
10.
10. Why?
Because that's a isosceles.
This is an isosceles triangle. So this is z, then this must be z also. Understand? And that's all about the question. You just have to explain in detail. Understand? Any questions? Okay, ladies and gentlemen, with this is the official teaching lesson for me. Okay? Official teaching lesson. By tomorrow, we will have our review. So tomorrow, come with only, I don't want to see this tomorrow. I want to see your review question. And make sure you have done some of them. Your paper is when? Monday or Tuesday?
Tuesday.
Okay. But we only have this weekend. Do some of them. Bring questions to class tomorrow so that we can review together for the last time. And we can take photos too. I'm not sure we have time to take photos today. We are coming with your PE uniform tomorrow also, right? And we still have a review today also. So it's not really the last
Tomorrow
class.
is review day.
After the exam. So we still have a review day.
But that doesn't count.
It does.
Not as math class.
Wait, it's the math class because I'm going to be doing solution of math stuff. So give us a
Magic.
for a wonderful year. Okay, let's start cleaning, people.
Magic.
Go. Let's start the cleaning. Oh yeah.
Not today, maybe not today.
I
I'm not
think it's
feeling it
Rihanna.
today. I'm more nervous. I'm getting more nervous. You guys,
I'm coming out.
We are cleaning, we are removing the posters. We are clearing your locker, I think. Let me talk to Miss Rosalie.
great. John, you're gonna make our last class of the year. Should I stop recording?
Magic.